Good afternoon and welcome back to the workbench, where today we have some stuff that could go bang but hopefully will not. The stuff in question is a little switch mode power supply, specifically a what was it? TD-551W. It's out of a 551W thin client PC, which has an inbuilt LCD. Now this power supply is kind of half an ATX power supply, and I say that because it has only 3 of the voltage rails you'd expect to see out of the 5 in an ATX power supply. It has a 5V standby rail, it has a 12V rail, and it has a 5V rail. There's no 3.3, there's no -5, there's no -12. It has a power PS on signal with a green wire, just like a normal ATX power supply. There's no power good output or anything like that. There's basically 2 supplies in one. There's a little 5V standby transformer here with the switching IC, and then you've got the main 12 and 5V rail supply with its transformer, switching MOSFET, and separate controller. Anyway, so and the fault with this thing is that the computer, the little terminal thing, wouldn't power on most of the time. I first tried to fix this, or first tried to have a look at it, probably about 7 years ago, which is quite a while. And I never really tried that hard on it, and I never really got anywhere with it. And it's just been sitting around for the last 7 years. And I thought, well, you know what, let's have a look at it again and do it properly this time. Or at least that's the idea. So, I started out by checking the voltages again, and I thought, well, let's have a look. The important thing, oops, just turned off. The important thing is to note that obviously the 5V standby circuit runs all the time, as long as the mains is plugged in, or at least it's supposed to, and that does feed some power to a startup opto-isolator, which controls power to the main supply, or the 12V and 5V supply, when the PS on signal is detected, obviously, from the main board. So the 5V standby circuit obviously has to be working fine before anything else can work, so I thought, well, you know, let's have a look at that first. Let's forget about the other rails, let's just focus on the 5V standby and see if that's going properly. So I plugged it in and measured the voltage, and I'll show you here what that does. Let's just grab this. And I plug it in, it comes up kind of slowly, and we get about 4.7, 4.6 volts, and the output does look pretty stable at that voltage. So, you know, it doesn't look too bad, and I think originally I may have tricked myself when I first looked at this, because 4.6 volts, you know, is fairly close to 5 volts, and even when you unplug it, it actually spikes up to 4.8, which is kind of strange. But yeah, assuming that it is basically an ATX power supply, 4.6 volts is not that great, but at the time, maybe it was higher when I measured it 7 years ago, I don't know. But at the time, I thought, you know, maybe that's not a problem, and I didn't really think much of it and kind of ignored it. But now, when I look at it again, I'm kind of thinking, hey, you know, that is kind of on the low side, and it's a little bit suspicious. So let's actually do some more tests. Let's just do more than a voltage test, than an open load, no load voltage test. Let's actually give it a load. So, hang on, I should have just left this plugged in. If I plug it back in again, I've got some little power resistors here. Well, not very high power, probably like 2 watts each. 10 ohms, got 4 of them in series, 40 ohms, that's 250 milliamps or so on 5 volts. Not a lot, should be able to handle that, right? Transformer's pretty good size for 250 milliamps, probably. Well, if we attach this, it'll goes even worse. Voltage drops to 2.1 volts, and this has gone down. So that's pretty terrible. Now, I would think that, given the size of the transformer, given the size of the diode, given the size of the thing, it should be able to handle 250 milliamps, no worries. But it can't. It can't even do 3 volts. So something's definitely weird. So that's an interesting thing. Now, a classic problem could be the output capacitors have failed. But in that case, I would not expect the output to be steady, and that is strange. Why is it perfectly steady? I don't know. So that's on the final output part of the circuit. We get 2.2 volts, and it's stable waveform. Seems odd. Okay, let's probe a little bit further up the circuit. So if we go, the output of this is a pi filter. It's got a capacitor and an inductor, then another capacitor. So if we probe halfway through that filter on the input of the inductor, we can see what we get out of that. And if I plug it back in again now, we can see, that's not stable at all. Okay, it is in the middle of a filter, so it could be that it's just, it's supposed to look like that, but that doesn't really make sense because we've got about 2 volts here, a spike up to about 5 volts. It's only briefly though, there's hardly anything there. Very low duty cycle, probably like 10, 20% or something. Certainly pretty terrible. You'd expect it to be a lot better than that. So yeah, no wonder the supply is only putting out 2.5 volts. It's only got about 2 volts or something actually stable, and then above that it's just a bunch of spikes, which basically aren't going to do anything. So of course the capacitors can't be charged up, and with a load it's only half what it should be. So again, I have a couple of theories about this. One of those capacitors could be bad, could be the one over here is bad. I don't know, haven't checked it yet. But another idea, which I think is possibly more likely, in addition to possibly the feedback circuit could be buggered, but I think my guess is the most likely suspect is probably one of these capacitors here on the primary side, and these supply power to the actual switching chip. So basically, if you have any idea of how these basically work, the chip, one of these capacitors will get trickle charged through a startup resistor, and when it reaches the turn on voltage, the chip will start oscillating once the voltage on that capacitor has reached the correct voltage. Once it starts oscillating, the power through the transformer will induce power out of the output windings. One of them goes to the output here, the 5 volt standby. Another one actually feeds back onto the primary side circuitry and actually supplies power to the chip. So the chip basically supplies power to itself in a way. And this filter capacitor here will filter that output and keep it steady while the chip is running. So the load the chip is making on its own power supply, it all makes sense. It all stays stable. But if these capacitors fail, if they go high ESR or low capacitance or open circuit or whatever, the voltage won't stay very, very high. And when the chip tries to power on, it'll get a brief burst of power from the capacitor, and then the power will all be used up, and the chip will just shut down because it's got no power. And then the capacitor will trickle charge again through the resistor, the startup resistor, and the cycle will repeat. So I think that's probably what's happening, is the chip is just starting up over and over, and it's pulsing the transformer with a small burst of power, but it runs out of power because this capacitor is probably bad, and they just can't do anything. That's my guess anyway. It could be something else, completely different. It could be the chip is faulty. I don't know. But I think it's most likely that capacitor there. So I'm going to take that out, measure it, replace it, and we'll see what happens. Okay, so I've pulled these capacitors from the circuit, and I've found something interesting. These two here are actually both in parallel. to provide the startup and run capacitance for the IC. Both of these are actually tested pretty much fine. If we have a look at them on this capacitance meter here, they're measured, rated at 47 microfarads, and we can see they do get approximately that. I mean, 42.9. That's pretty close. And this one here, 40.4, 42. That's within tolerances easily. And their ESR spec is pretty much okay as well. So I'm not entirely sure why I'm showing you this, because I probably don't need to. But, you know, let's have a look, right? 1.1, that's pretty good for a small capacitor like that. That's what you'd expect. And 1.4. So, you know, those ones seem relatively okay. I don't think there's anything wrong with them. However, we go back to the output filtering capacitors, and things start to get a little worse. So, for example, this one here is supposed to be 470 microfarad. This is the final output capacitor after the coil, and this one measures now, if I can get it in here, that's measuring 400 microfarads. Now that's not terrible. I mean, it's almost within 20% tolerance, but it's pretty close to the edge, so it's not that good. I'd expect at least 420, 430 out of it. And if we check the ESR, it's okay. I put 0.1, but I don't know. Could be a bit lower, I think. Well, this may be a general purpose capacitor, I'm not sure, rather than a low ESR one specifically. Anyway, it's marginal. It's not great. It's marginal. It'll probably work, but it's kind of a bit funny. And then we get to this one, which is the first output capacitor straight off the rectifier diode in front of the coil. We check this one. It's supposed to be 1000 microfarads, but it's only coming up as 414, 420. So it's basically half, less than half of the capacitance is supposed to be. So it's definitely bad for a start. The capacitance is pretty much halved, and if we check the ESR, well, that's really terrible. 8 ohms, 8.2 ohms. Now this should be better than this one. It should be 0.1. It should be 0.05 or something. It should definitely not be 8. So this one's bad. This one's completely bad. It's not bulging at all. It looks perfectly fine. It's most likely dried out because it's an 85°C part, and it hasn't vented, so it's probably just dried out from too much heat in old age. It looks like one of the original ones from this power supply, because before I just went and took it out, the solder joints were basically factory fresh. So never been worked on, as far as I could tell, unless someone was very, very good at cleaning the board. These capacitors here, these had already been previously replaced or tested when I got it, but these G-Luxon ones, I think these seem to be the original ones there, because the solder joints look just pristine and never touched up at all. So it looks like someone had previously worked on this before me, actually, and had replaced some of these capacitors. I think these ones, what are they? Jamicon TK series, 105 degrees. I think these are the ones that the person has put in themselves. Probably maybe they found some of these were already blown, but this looks like an original, and it's bad now anyway. So yeah, that could well be the problem. Maybe the IC supply capacitors are fine, and maybe it's this one that's the problem. So I'll put a new one of these in, and then we'll give it another test and see what happens. Alright, so I just replaced the two output capacitors, the ones that didn't test very well, especially the big one, which tested pretty awful, and I put a new Panasonic FM in place of this one, and a Rubicon ZL in place of this one. Right, so now let's power it back on again and see what happens. Obviously I've got the multimeter hooked up, I've got my load not connected at the moment, but we will connect that shortly. And I've got the oscilloscope connected to the point at the input of that inductor where we were getting those horrible voltage, well, not voltage spikes, but we're just getting spikes to 5 volts rather than a continuous 5 volts, or at least something close to close to continuous 5 volts would be what I was expecting. Okay, so let's have a look and see what we get now. Okay, that's without a load, and we're getting 4.993 volts, so that's a lot better than 4.6. It's much, well, that's pretty much bang on 5 volts, isn't it? Just about. Anyway, and we've got a nice stable trace here, so we don't have any flickering around at all, nothing funny going on. All looks good. That's without a load though. Let's try actually connecting the load resistor. Okay, so the voltage has dropped to 4.98. That's still really good, and the scope trace is still perfectly stable, so no funny business there. So awesome. So that looks like that's solved that problem of the 5 volt standby rail being completely rubbish. It was just these capacitors. Not the capacitors I thought it was initially, but capacitors all the same. So there we go. That was that problem. So if you're troubleshooting a switch mode power supply and it's supposed to be doing whatever it's doing and it's putting about half the rated voltage, well, check to see if one of your output capacitors hasn't gone to half the rated capacitance and about 8 ohms ESR. So really this one was basically doing all the work, and this one was pretty much doing nothing because the ESR was so high and the capacitance was so low. So that was fun. Not an incredibly difficult bit to repair, but interesting all the same. So hopefully that was a bit of interest to see what the kind of output waveform you get with a really bad capacitor. Really terrible ripple, and I honestly did think that the switching IC might have been running out of power and not being able to run, but no, apparently it was the output capacitors that were bad. And kind of surprising given that the final output was perfectly stable, and yet the intermediate sort of filter voltage was really, really horrible. So I think that's kind of a bit tricky, you know. I would have expected if the just take these off. I would have expected the final output voltage to be full of ripple and noise as well, but hey, I guess that wasn't the case. Maybe the filter circuit was pretty good, and maybe this capacitor was still good enough to fix the ripple, but at the expense of having the voltage at half what it was supposed to be. So that's quite interesting. Oh yeah, so sometime later, and I've put the power supply back in the terminal, and I've hooked some stuff up to it, and I'm going to just give it a little demonstration here. So we can see the thing here. It's basically here's the power supply, obviously. We've got a little motherboard here which has a National Semiconductor Geode GX1 on it. It's old enough that it's still got the National Semiconductor logo on it as well. It's even got an IDE port, and I've plugged in a little compact flash micro drive, hard drive, 4 gigs out of an old iPod, I think. I got it second hand on eBay. You can get them from China for a couple of dollars, I think, or America. Actually, can't remember where I got it from, but anyway, it works. It was cheap. It's perfect for this kind of thing. And this motherboard actually also has a socket next to the BIOS chip down here, which you can install a disk on chip, which is basically a high capacity flash drive in a DIP package. And I've taken that out so I can boot off the IDE port instead. Otherwise the motherboard BIOS just defaults to that. And that's got Windows CE on it, which is what normally runs on this as a thin client thing, and then it connects to like a server somewhere, and you get all your stuff off that. But I just want to run it as a standalone sort of computer. So I've unplugged the disk on chip, and I've put a IDE cable in, and I've attached an old power supply cable from a old dead ATX power supply that I've soldered onto the bottom of this connector here on the PCB board side. PCB board, sorry, the PCB. And there we go. So this motherboard is a TK3000B, which is made by TermTek apparently. And it does have a BIOS, sort of a standard PC BIOS. So I turn it on. I can show you how this thing goes. So if I press F12, because the F12 key is for this. Delete doesn't work, obviously. It's kind of different, but the setup is basically the same as any other. You've got the usual options and stuff. But yeah, anyway, so I've connected this little drive here, and I've installed DOS on it at the moment. This motherboard, I think, can support up to 256 megs of RAM, I think. It's got one SD RAM slot. Not entirely sure if it's 256 or 128. It's only got 32 megs in there at the moment, which is fine for DOS, but I'll probably upgrade that later if I do anything significant with it. Oh yeah, so I had to hook up a CD drive, obviously, to the IDE port to install DOS from, and I discovered how to do that. It's a little bit tricky at first because obviously there's no floppy drive connector on this at all. That I can see, even though the BIOS does have option for enabling one, but doesn't seem to actually have the physical connector. But if you get a standard DOS boot disk CD ISO, which you can find on the internet if you just Google for that, this is DOS 6.22, the last standard version of DOS. If you find that ISO, you download that, you can edit the ISO. It's got like the DOS boot sector and everything in it already, but if you edit the ISO with a ISO editor, I've used ISO Master on Linux, but I'm sure there's like ISO Magic or WinISO or whatever if you're using Windows, and I'm sure there's Macintosh stuff as well. And anyway, edit that and just add the contents of the 3 DOS installation floppies into the same folder on the CD. Now, the trick then is you can boot from the CD because it's already got the boot image and everything on there. And once you've booted from the CD, you go into the folder with the installer files you've copied. And the trick is that instead of just running the installer directly from that folder, if you do that, it won't work. It'll try to install, but it will complain that you need to insert disk 1 into the floppy drive, which obviously you don't have because you're running off CD. But to get around that, before you start the setup program, what you do is you just run fdisk and you create your partitions, and then you run format and format the drive. And you do that all first, and then reboot, and then you can load the installer, and then you just tell it to install, and it'll detect the partition, detect drive C, and it'll install, and won't complain about any disks being missing, or at least mine didn't anyway. So anyway, there's obviously upshot of that. I've got DOS installed and working, and I'm going to show you that, well, obviously you can see here it works, but I'll just play a classic game here, which is one of the old ones I used to play a lot. This is, some of you might notice this, notice it, I mean some of you might recognize this. We've got the delightful onboard PC speaker sound, which is delightfully horrible, but still delightfully retro and fun anyway. So there we go. I probably won't be able to play this very well, but anyway, it works. Honestly, I have no idea how popular this game was, how many people remember it or anything, but I played this when I was about 13, I think. I played that quite a lot. It was quite fun, and I've always quite liked it, along with Prince of Persia and a bunch of other ones. Yeah, but you can see, surprisingly, for such an old computer with LCD in it, the LCD is actually surprisingly responsive. I mean, if I've got some more modern monitors that if I run this game, and other ones obviously, but this specifically, if you run it on them, the animation effect is very blurred and very dark, and in this it's actually really responsive and really good. And obviously I'm crashing into walls because I can't play and look at the camera properly when I do this, but you know, there we go. It yeah, surprisingly responsive. So I imagine this thing might have been quite expensive when it was made, and it certainly seems quite well built in general. But there we go. So yeah, I mean, it works. Yeah, I might use this thing maybe as a little DOS gaming computer, or maybe I mean, it's got serial and parallel ports, so it could be quite useful for hooking up old test gear and stuff, things like that. Maybe even running some sort of CNC thing in the future, maybe. I don't know. It'd be quite nice because it's all like a nice little self-contained thing. It's even got a little audio amplifier and speakers in the base that stand that the monitor goes into, and you know, I mean, if I can mount this little drive inside and all that, and yeah, it'll be quite good. So can probably do something quite useful with this. Even though it's only 300 megahertz, and like I said, it probably only supports up to about 256 megs of RAM, but that's fine for, you know, DOS or Windows 3.1 or Windows 95. And you could even cram Windows 98 on it probably, but I don't think I'd bother. If I did, I'd probably install Windows 95 on this, but maybe even just keep it with DOS. But anyway, there's one other thing I suppose worth mentioning with this is the when I first started trying to fix this thing 7 years ago, I got quite confused by the output voltages from the power supply, because like I said, it has a 5 volt standby which was obviously low. It was faulty. I fixed that before, as you saw. I didn't figure that out back then, but I figured that out more recently. It also has a main 5 volt and 12 volt rail which powers the motherboard and the inverter, and an LCD panel I think runs off the 12 volt as well. But I was confused because when I would power it on, occasionally it would power on even though the 5 volt standby was bad. When it did power on, the 12 volt rail would spike to over about 16 volts when it first powered on for a couple of seconds, and I was kind of concerned that, you know, maybe there was a fault there and it would damage the LCD or the inverter or the motherboard or something, or whatever. But more recently, having more look into that, and following some advice that I got on badcaps.net, where I posted about this thing a long time ago, I sort of got disheartened by it, I guess, at the time, and wasn't really skilled enough to sort of do it properly, and I didn't really understand about switching power supplies as well as I do now. And now that I look at it, I traced out the circuit and I looked at the thing, and following the advice they gave, and they said, you know, the feedback, it has two rails, 5 volt and 12 volt, but the feedback for the power supply is only for the 5 volt rail. So the 12 volt is basically just sort of unregulated and untracked, I guess, by the controller. So basically what happens with this thing is when you power it on, for the first second or two when it's starting up, the motherboard is drawing obviously probably full current from the 5 volt rail that it draws, as it's just starting up, and obviously that means the 5 volt rail would go low, but the feedback back to the controller will mean a duty cycle to the transformer, and that will increase, and the voltage will stay at 5 volts, which is how you'd expect it to do. But because the inverter and LCD run off the 12 volt rail, and the inverter I think draws the most current on the 12 volt rail, it doesn't kick on, it doesn't start up immediately. It takes a couple of seconds before it turns on. So before it actually starts up, the 12 volt rail has a very low load on it. So you've got the PSU is driving a higher duty cycle than with no load to supply power to the 5 volt to keep that constant, because that's where the feedback is coming from. But of course, the 12 volt having no feedback, it's got a light load compared to the 5 volt rail, but it's got the duty cycle pulsing to the transformer as if there was a heavy load on it, because the only monitored rail is the 5 volt rail. So the 12 volt obviously is unregulated, it therefore goes up, because the duty cycle that's being fed to that rail is too high for what it would need to be with a low load if you wanted to keep it at 12 volts. So it rises up to about 16 volts, and then once the inverter actually kicks on, the load is at the correct level, and the 12 volt rail then actually drops down to 12 volts and everything is normal. And you can confirm that by looking at the inverter. Actually is quite basic. It's running off a TL494, so it doesn't actually have a standard application specific inverter chip. It's just a basic TL494 that can handle up to 40 volts or so, that's no problem. And the LCD panel itself has all onboard regulation and all that for the voltages, so I mean, yeah, 16 volts is not going to be an issue for either of them. So I was basically worried about nothing whatsoever. And clearly, looking at the design of the PSU and the whole feedback thing and how that works, it's pretty obvious when you think about it logically and you understand it that yeah, it's just an unregulated rail, and it will naturally go high when you've got a heavy load on the feedback monitored rail and a very light load in comparison on the unregulated rail. That's just the way it would happen. It's not really physically possible to do anything about that unless the PSU was designed a different way. So that's just how it is. But yeah, one capacitor in the 5-volt standby rail and the thing wouldn't work, and replace that and now it all works. So I hope that was an interesting video. I hope you enjoyed that. I hope maybe you learnt something interesting from that, and I certainly did. So I guess that's it for this one, and I'll see you next time.